Computer performance. In computing, computer performance is the amount of useful work accomplished by a computer system outside of specific context. Computer performance is estimated in terms of accuracy, efficiency, and speed of executing computer program instructions. When it comes to high computer performance, one or more of the following factors might be involved: short response time for a given piece of work, high throughput or rate of processing work, low utilization of computing resources, fast or highly compact data compression or and decompression, high availability of computing system or application, high bandwidth, and last, short data transmission time. Aspects of performance. Computer performance metrics, things to measure, includes availability, response time, channel capacity, latency, completion time, service time, bandwidth, throughput, relative efficiency, scalability, performance per watt, compression ratio, instruction path length, and speed up. CPU benchmarks are available. Availability. Availability of a system is typically measured as a factor of reliability. As reliability increases, so does availability, that is less downtime. Availability of a system may also be increased by the strategy of focusing on increasing testability and maintainability and not on reliability. Improving maintainability is generally easier than reliability. Maintainability estimates or repair rates are also generally more accurate. Response time. Response time is the total amount of time it takes to respond to a request for service. In computing, that service can be any unit of work from a simple disk I/O to loading a complex web page. The response time is the sum of the three numbers. Service time, how long it takes to do the work requested. Wait time, how long the request has to wait for requests queued ahead of it before it gets to run. Transmission time, how long it takes to move the request to the computer doing the work and the response back to the requestor. Processing speed, most consumers pick a computer architecture, normally Intel IA32 architecture, to be able to run a large base of pre-existing, pre-compiled software. Being relatively uninformed on computer benchmarks, some of them pick a particular CPU based on operating frequency. Channel capacity. Channel capacity is the tightest upper bound on the rate of information that can be reliably transmitted over a communication channel. By the noisy channel coding theorem, the channel capacity of a given channel is the limiting information rate in units of information per unit time that can be achieved with arbitrarily small error probability. Information theory, developed by Claude E. Shannon during World War II, defines the notion of channel capacity and provides a mathematical model by which one can compute it. The key result states that the capacity of channel as defined above is given by the maximum of the mutual information between the input and output of the channel, where the maximization is with respect to the input distribution. Latency. Latency is a time delay between the cause and the effect of some physical change in the system being observed. Latency is a result of the limited velocity with which any physical interaction can take place. This velocity is always lower or equal to speed of light. Therefore, every physical system that has spatial dimension different from zero will experience some sort of latency. Bandwidth. In computer networking, Bandwidth is measurement of bit rate or available of consumed data communication resources expressed in bits per second or multiples of it. Examples is bits, k bits, m bits, and g bits. Bandwidth sometimes defines the net bit rate, aka peak bit rate, information rate, or physical layered useful bit rate. Channel capacity or the maximum throughput of logical or physical communication path in a digital communication system. Scalability. Scalability is the ability of a system, network, or process to handle a growing amount of work in capable manner or its ability to be enlarged to accommodate that growth. Power as consumption. The amount of electricity used by the computer. This becomes especially important for systems with limited power sources such as solar, batteries, or human power. Benchmarks. In computing, a benchmark is the act of running a computer program, a set of programs, or other operation in order to assess the relative performance of an object, normally by running a number of standard tests and trials against it. The term benchmark is also commonly utilized for the purposes of elaborately designed benchmarking programs themselves. Profiling or performance analysis. In software engineering, profiling or program profiling, profiling is a form of dynamic program analysis that measures, for example, the space, memory, or time complexity of a program, the usage of particular instruction, or frequency and duration of function calls. The most common use of profiling information is to aid program optimization. So here's the references